So we hit create on that. And what happens is now we're in studio mode. And in studio mode, we're essentially creating examples for this detector. So these are examples of cars and examples of man holding gun. So let's add more examples of cars. We can go ahead and actually deselect the examples. This is our own mini search engine off of public data sets, off of the web, the Common Crawl, and other places. This doesn't seem like such a good example of a car, so I'm going to deselect it. I can go in and select particular areas that are more relevant to cars and essentially curate my data set. If I can't, if Matroid fails at finding examples, then it's up to the user to upload their own examples. And so here, I can upload examples from the computer. So let's say I was uploading examples of cars. Test media, I have an example of a car here that is a reasonable example. So that's no surprise. That's, of course, I can do that. Here's more interesting. So this is where you see our own video player at work. So we're looking for cars, and there's a video of cars driving by on the Golden Gate Bridge. And so this is our own video player, and in the video player, at any point you can say pause. Well, this is not a good example of a car. This is a reasonable example of a car. So you can pause. Once you pause, you have this essentially selector that lets you select areas for where cars occur. So a car here is here, another car is here, and another one here. So these are reasonable. And because we have a full video player, the sequence information is actually preserved. So we know that this is 3 different frames in a video that are one after the other. So the time information can be fed into the neural network separately. So we upload these frames, and then we go in, and we want to make sure that we actually select the area that's car-like, not pick out that person. So we select the car here, And this studio is actually designed expressly to minimize the amount of clicking you have to do, to the point where we've even gotten keyboard shortcuts going, and we want you to get out of this mode as soon as possible, out of the mode of creating a detector as soon as possible. So now we've given some examples from our video. We can even go to recordings from streams. So this is actually this is live. This is somewhere in Louisville. This is some camera that is public in Louisville. We can record from this camera so that if later we're going to run the detector on the camera, we pick up all of the nuances in the stream, like if there's glare on the camera, if there's some object that's always confusing in the stream, we can normalize it out essentially. So what we would do is we would record from that and then use it. This is actually the Matroid office. This is the Matroid office right now. This is live. So yeah, this is where I sit, and I'm obviously not there. So these are recordings. So here's a recording of the Matroid office, and you would go through and you would select snippets from that as usual. So this is essentially trying to get you out of, make it as easy as possible to create a detector and out of detector creation mode as fast as possible by making it as easy as possible to bring in all these different sources of media. Finally, I'm going to select natural imagery as my model type. And that's it. So I'm going to create this detector now, and it's 4:32. So we'll come back to this page in 3 minutes. That's how long it'll take to create the detector. That's one other thing, is we've really worked on bringing down the training time. So let's look at some other detectors that we've already built. So these are detectors that are already built. I have hundreds of them. And this is a detector that can detect Steve Jobs, Eric Schmidt, Brian Krzanich, and Jerry Yang from Yahoo. So what I'd like to do is search a video using this detector. And I have a video of the iPhone being unveiled that has all those people in it. And well, not all of them actually, some of them. And so in this video, we would be wanting to look for, say, Eric Schmidt or Steve Jobs or whoever. So Eric Schmidt shows up in this video to say, look, Google.com works well on the iPhone. And if you look at this, the timeline's been annotated with where we think Eric shows up. So far he hasn't showed up, and then we think he shows up around here. And there he is. And then his face gets tracked whenever. We do need more or less most of the face in there, so to be able to track him. And this, we made this detector in exactly the same way as you saw me make the other one. And he goes away for a second and then he comes back. And then Jerry Yang shows up to say that Yahoo.com works well on the iPhone, and then he should be around here.
I'm not a board member of Apple, but I would love to have one of these too, obviously.
So he's around for a while, and then he goes away. And Steve Jobs is, of course, all over the place. And Brian Krzanich, the CEO of Intel, doesn't really show up. There's a blip here that's wrong. So we do have false positives, okay? I can't say we never have false positives. But then you can see, with the slider here, you can change how certain you want to be in the blips that show up. So you can get, if there are false positives, you can set it to a level that you're not wasting your time. So this is an example of something very obvious, right? Everything. You can, of course, try images, URLs. You can even try the webcam on my laptop, actually. And you can, of those streams that I showed you, you can ask us to monitor that stream using this detector for whatever this detector is good at finding. So this is something that we provide as a service. We have all of these streams coming at us. Making a detector is free, but if you wanted to watch a stream, to watch a stream for you, that's where we incur computational costs, and that's where we make money as well. We ask for some cost to monitor a stream. Everything I showed you is available through an API. You can do everything from classifying an image to registering a URL to search it, and all the other things that I showed you. Let's see. So it's 4:35. Let's see if our detector is done. It is done. So this is the detector we just made. Let's rename it so we don't forget it. Let's call it the Fermilab detector. Okay. Fermilab car detector. And then what can it detect? It can detect a man holding a gun. So let's go and look for that. Let's see. So there's this Clint Eastwood movie where he actually pulls out a fake gun, and then he pulls out a real gun, and hopefully we can figure that out. So the previous detector that I showed you had actually seen the video before, so the computation was like much more snappy because it was cached. This is happening right now. So we uploaded the file. I'm on EduRoam, so it's pretty fast, and it's a 14 meg file, so that was fast to upload. But then this classification is happening right now as we're watching it, and we're looking for a man holding a gun, right? So we want to be fairly sure that it's a man holding a gun, and we think there's a man holding a gun there. This one is actually wrong, but if we so let's go to this is where it gets more interesting. How many of you have seen this movie? It's Gran Torino. It's a good movie.
That's me.
Come on. So.
You fucking crazy, man. Get out of here, man.
Why don't you get your ass up out of here before I kick your old wrinkly...
Okay, I should. So this is where he takes out the fake gun. Yeah, no gun there. He points it around for a second, and then this is where he takes out the real gun. So it's a man holding a gun. There's a part where there's a man. We don't get that because that's not so much a man holding a gun. And there's a part where it's just a gun, and that's not a man holding a gun. All the examples were man holding a gun, not just gun. So theirs is where we get that. And then the gun itself actually goes away for a second, and then it comes back. Same deal with, so if we happen to make a mistake on a video, right, we would want to be able to give feedback. So this is sort of a poor man's reinforcement learning. A poor man's reinforcement learning is as detections or as things happen, you would want to be able to give feedback immediately so that the model can learn from its mistakes. And this is exactly another reason why we had to build our own video player, is so that we could give the current flame as either a positive or negative example to the thing. So, that's a bug. So this went away. It comes up for a second, and then, that's a bug. So we should be able to give this as positive or negative example to the man holding gun or to the other one. I wonder if it's because I have weird resolution. Yeah, I can still click it, but the weird resolution makes it hide away. So I'll make a bug for that. This is a very strange resolution for us, so I'll fix that. But you understand the idea there. By having our own video player, we can pick out frames in the video and send it back to the detector. We create the detector so we can iterate on it. It's not real time. So once you're done creating, once you're done giving feedback, you then have to redo the detector. Yeah, redo the detector. So that's a good segue onto the next thing I wanted to tell you about is redoing detectors. So we have our own library of detectors. There's a very wide variety of detectors that are available for use, and you can take any one of these and sort of change them. So this is one that detects whether a person is wearing glasses or not. And let's see if it works on me, actually. If it doesn't, well, we can give it feedback, but hopefully it works on me. Nah, it didn't work. So this is some kind of weird. So let's say this is wrong, the choose label, and this is a person not wearing glasses. And so I can use that. Then when I hit redo, I go and what happens is when I hit redo, I'm back in studio mode, and I have all of the examples that were provided. And in studio mode, I can look at, first of all, these are examples of people not wearing glasses. And then these are examples of people wearing glasses. And then there's a negative feedback for that. So negative feedback is right there. There's me. It already tagged my face to say that this is a face. At least it got the face right. Yeah, so it's having trouble. That's why. Yeah, but well, now we have to tell it that, right? So we would want it to be able to pick out things in dark environments as well, and we would want to give it something better, right? So then I would hit create again and redo the detector. So let's delete that detector because we don't want to actually work on it right now. And there was one more thing on the other not the tech leaders. The detector we just made, the Fermilab detector, it could also detect cars, right? We didn't really run cars, and I wanted to show you what happens if you put in a YouTube URL. So a YouTube URL that you hadn't seen, that this thing hasn't seen before, should also just work, right? And indeed it will. So it will. We go to YouTube, we talk to YouTube, say, hey, look, we want the frames for this video. We get them, we classify them, and at the same time that they're being given to Matroid, they are also being given to the client. So YouTube is actually streaming to two places, and then again the classifications happen exactly as though you had uploaded the video yourself. So this is a lot of engineering work to basically give you the same second anniversary of Tesla's entry into China. Experience, regardless of whether it's a streaming video or so there's no cars yet, and then the cars should show up here. This is the trunk of a Tesla car. So this is a Tesla ad. Surprisingly, there's not cars in a Tesla ad the whole time. And so it goes away and it comes back. It's sort of hard to see.
China is the first country in Asia
and then it comes back for a second.
Not only is the Tesla clean, but it's also safe, it's fast, and it's really cool to drive.
So the whole frame gets the border when it's the whole thing. All right, so you see how it's pretty easy to make your own detector and use it and use the video player to understand how well it's working and iterate on it. Now I want to show you the part that is more academic, that is more towards towards more data science, and everything you've seen here is like almost usable by a determined teenager. It's at the level of someone who can use Photoshop, and we built it deliberately that way so that a vast number of people can use it. But now let's say you are a much more sophisticated machine learning engineer, and you understand neural networks. You understand what it takes to build one, train one, and you want much more statistics about the model that is underlying. And you might even want to upload your own model and change your model there. So for that, we have this whole other interface that essentially goes into advanced mode for Matroid. So these are public detectors that I could build on. I actually want to build on one of my detectors, which is a table and chair detector. Table or chair. And then we go into Matroid board, which is actually a building off of Tensor board. How many of you know about TensorFlow? How many of you know about Tensor board? Okay, so what you'll see is essentially, this is loading, it's essentially are piggybacking off of TensorBoard. So that detector, this detector detects tables and chairs. As a machine learning scientist, I definitely want to know what the accuracy of my detector is for tables and chairs. That's a no-brainer, right? And so you get that here if you want to go into advanced mode and understand what's going on. More interestingly, you can also see on the training examples what the false negatives and false positives are immediately there, so that you don't have to go looking for them yourself in the video player by trying examples. Just if the detector is making mistakes on the training examples, you should just be able to see it. And so you can, and these are the examples that it makes mistakes on in the training set, like this weird chair embedded into the table, or usually chairs don't have flowers on them, so it's probably confused by the fact that the chair has flowers on it. It thinks most things that have flowers is a table, and so on. There are all these weird examples here, right? But now you understand why it's making mistakes. You can look at the neural network that's underlying it through these nice visualizations, and then you can go in and change what you will change the architecture as you so please. This is essentially where we're building off of the open source framework as much as possible. We'll be allowing you to upload your own models as well, your own architectures as well, and we will be providing more and more architectures here. There are distributions for the weights, histograms on the weights, and this is pretty cool, is the embedding. So once you have a detector, you can look at how it's embedding the training data with regard to the label. So this is the training data. It's been embedded using some embedding, and then these are hopefully the orange ones are the tables, the blue ones are the chairs, and hopefully you would have a very fine separation, but there's not. There's a lot of stuff in the cloud that is overlapping, and these are this overlap is exactly those examples that you saw that the mistakes were made on. So we're going to build on this quite heavily, and you'll see us. You'll be able to, in advanced mode, essentially upload and change the neural network until you get to a point where things work out for you. If already you can't find something in the public gallery that works well for you. So in the public gallery, let's say I have that the tech icons detector, right? So this was this is the public gallery of detectors. This is a detector that can detect a bunch of these people, right? I want to add, say, I don't know, it's Ginny Rometty, the CEO of IBM, to that. I would just hit redo, and I can add Ginny in there, and then hope that it works well. And if it doesn't, I know what to do. I have to find more examples. Hopefully, I won't have to redo the architecture myself. Although for physics applications and really esoteric things, we probably would have to create your own architecture. So I would not expect this to work for some really weird things that come out of physics experiments right now. Because the reason we can train quickly is because we have a bank of something like 10 different pre-trained networks. And these pre-trained networks, we actually look at them all and say which one is the best one for the sake of this training data that you've given us. And then we pick that out and use it. And so we don't have a pre-trained network that is particularly good at really esoteric electrons bouncing off of something, and then you took a picture of it. We don't have examples of that, right? But if this interface is helping you with your own custom networks, that would be great. So this is something that I want to talk to folks about, see if that's possible. Let's see. So you can, but the point here was that why did I go and redo this tech